Here we go. Welcome to day 2, problem 1. We are finding out what number correctly completes the equation. And I'm looking here and it's giving us which one is going to, if we multiply it by 100, is going to give us 6,400. Well, one way that you could figure this out is if you're not sure, is you could make a number line. So I'm going to put my decimal here. This is the tenths. This is the hundredths. This is the ones. This is the tens. Oops. This is the hundreds, and this would be the, oops, that's not the hundreds, that's the thousands, and then the thousands. So we're looking for 6,400 to be our product. Remember when we're multiplying on the number line, our value increases by 10. So in other words, if I had 1/10, it would be times 10 would give me 10. 1 times 10 gives me 10. 10 times 10 gives me 100. So I'm going to break this up here to help me figure out how many times I move it on the number line. Well, I know that 10 times 10 gives me 100. So that would say the same thing here, 1 times 10 times 10. 2 place values, I move it on the place value chart. So we're going to use our place value chart. We're going to put in here 640. And if I multiplied it 10 times 10 or 100 times, then 6 would go over on the number line to the left 2 times, 1, 2. Nope, that's definitely not going to be 1, 2, 1, 2, and I fill that in. That is actually going to be 64,000. So 640 times 100 does not equal 6,400. So let's try the next one, 64. So I'm going to put it here on my number line. I'm going to put the decimal here, and I'll put my whole number 64, 4 ones, 6 tens. Now I'm going to multiply 6 tens by 10 times 10. And I'm just moving it on the number line. I'm really not even having to do much math. So 6 times 10 would give me 600. 600 times 10 is going to give me 1,000. So 4 times 10 would give me 40. 40 times 10 would give me 400. Then I could put the place values in here, 0, fill that in here. 6,400. Does that equal 6,400? 64 is your answer. I hope this helped you. You can always do it the old school way and multiply each one by 100, and you can do it that way. So can you use more than one way to solve a math problem? Yes, we hope so. We hope you do that. Okay, problem 2, which is equivalent to 6/5 times 3. Remember the little song we sing, you put a 1 under it, put a 1 under it. And now we're going to have 6/5 times 3 over 1. And equivalent means equal or same, alike. And so we're going to just do numerator times the numerator. 6 times 3 we know is 18. 5 times 1 we know is 5. It's 18/5. Ooh, we don't even need to simplify it here because it already has the right answer. 18/5 matches 18/5. Beautiful. And then we have number 3. What is the quotient? Quotient we know is the answer to a multiple division problem. Ooh, this is the obelisk. We're going to divide by converting it into the house or the vinculum, how we like to say it. So 189 always goes in the house because this is the dividend, the total amount that you're dividing. It just goes in a different spot when depending on which sign you use. So here, this obelisk here, the dividend is going to be here, and then your divisor's here. When you're using the vinculum or the house, the dividend goes inside, the divisor goes on the outside. So 6 is going to come on the outside. Now we use the steps of division. We're going to bring this decimal straight up right away as we move it out of the way to kind of help us know exactly which each number goes. Can 6 make one equal group out of that? No. Can you make, how many equal groups can you make out of 18? Well, I know that's 3. So my 3 goes right above the 8. So I'm lining it up. Then we're doing 6 times 3 equals 18. Then I'm going to do 18, take away 18, which is 0. And then I bring down the next number, which is 9. And then I have 6 goes into 9. 1 times 6 is going to be 6. So I subtract that. I go 9, take away 6 is 3. I don't have anything else to do. I have a decimal here. So guess what? When you have a decimal, you have the opportunity to put a 0 on here without changing the value of this number. You can put a million zeros and it's still going to have the same value. So bring down this 0 now. It's going to help you. 6 can go into 30 how many times? 5 times. Did we find the quotient of this problem? Let's see. Can we 6 go into 30 any more times? Nope. 0 times. You're done. There's your answer. You can see it. If you wanted to check it, you could reverse it and do 315 thousandths times 6 and see if the dividend matches the product or the answer. And if they do, you've got the right answer, but I think we do. I think we're good on this one. All right, some more science. Problem 4. So a student used a string to tie a paper clip to a small weight, and then she moved a magnet about to observe what happens when the paperclip. The graphic below shows some of what she observed. So it says, which best explains why the paperclip seems to float in the air in figure 3. So we're not going to look at figure 1. We're not going to look at figure 2. We're going to talk about figure 3. So here is one of the choices. A says, because the paperclip has become magnetized. Well, the magnet being magnetized isn't necessarily going to keep it like that floating, right? So this one doesn't make sense. So we're going to take that one out. And then B, because the magnet still is exerting a force on the paperclip, I'm gonna hold on to that one. Let me think here. Because the paperclip is experiencing a gravitational pull, if the paperclip was experiencing gravity, it would be looking more like figure 1. So that one's definitely gone. Because the magnet changed the chemical properties of the paperclip is still a paperclip. It didn't change into anything. So this is definitely not the answer. So B, because the magnet's pulling strong enough to make it float in the air, right? It's the magnet's fighting the gravity. And so that's why it looks like it's floating and keeping that paperclip up. So your answer is naturally going to be B. All right. Can't wait to see your work. You're waiting for it.